Choose one.
Okay, so jumping right back into it, let's go ahead and do these visualizations. I went ahead and did a lot of this is you're used to me doing this, but it's important to note that I am giving you a lot in terms of labels, so it's imperative that you're cognizant of these things. These should be added to your plots, okay? So be aware of that. So with that being said, what we're going to do is answer the following question: what do daily high and low temperatures trends look like across several California cities? So what we need to make sure that we do is that we're looking at a data frame that has both the high and the low as a variable. So we're going to use the weather long data frame to actually answer this question. So here we're going to use the data frame weather long, okay? On the x-axis, ideally we should have the date or time, so we should be using date. Okay, the y-axis should be the actual temperature, temp-f. And the color is going to be either high or low, so it's going to be the temp type. And our line width is going to be, let's say 1. So if I were to do this is going to just show all the cities together. Let's see. Okay. All the cities together, exactly. So, but the thing is, we know that we have multiple cities. So what we're going to do is facet this based off of the city. Okay. And we're going to say just one column. So that could be on top of one another. So when we run this, okay, we have it on top of one another. That's cool. That's nice. Okay. So notice your graph is not going to look like mine because it's going to be a different 30 days. But the thing is, in terms of colors, I haven't spent time on the scale element of the, design, but you can specify the colors. So let's say daily highs are tomato. We can do that, like tomato red, tomato. Okay. And then you can say the lows are still blue because it's blue when it's cold. Run this. Okay, so then that's the color change. Okay, cool. We can add some more. We can add labels to our graphs. Okay, make it look nice. We can also remove the gray background by just making it minimal. Okay. And then we can make the dates be at an angle so it's not like, they're not repetitive, they're not over each other, but it's nice to actually just see, put it at a 45-degree angle. And we can just move the title just a tad bit to the far right rather than to the far left. And it looks something like this. Okay. So that is the end. That's our information for us to tell what do the daily highs and low temperatures look like across several cities. San Luis Obispo starts up high and it goes down, kind of go down. Oh, it's San Luis Obispo. Oh, yeah. So it goes down, goes back up, But then in terms of San Diego, it's quite steady, people like that. But they slow in San Francisco had that same peak, you can kind of see that. It kind of showed in terms of the high for San Diego. I could be a meteorologist for goodness sakes now. So that's quite nice. So yeah, so that is what we can then show, or at least talk about from this visualization. All right. So what kind of question is the line plot essentially good at answering? Something changing over time. Data changing over time. Okay, that's cool. All right. So how does the relationship between daily temperature range and precipitation differ across cities? So that goes back to our Y data frame. Okay, that goes back to our Y data frame, our 93 by 9 columns. So this one right here, right? So we're going to look at the precipitation for that day, as well as the temperature range. Okay. So let's do that. So the data frame is going to be mod 1. X is supposed to be the temp range. Okay. Temp range underscore F. I'm going to try something. I'm going to put this here, copy this, delete that, type it, and let's see if I start typing Y out. Let's see if it auto completes it for me. Precipitation. Yeah, it does. So that's a nice way to alleviate typing. And then color, we're going to say by city. Okay, so each row is going to be by city. Sorry, each color is going to be specified by city. And we're going to make this, let's make this 2. And let's make it a little bit more transparent. Let's make it 0.4. So we can see the values. And here we go. Here are the values. Again, this is going to look different from your visualization because yours is going to be from a different 30 days. So you can see in terms of San Francisco, there was a bit of some rain, but the difference in temperature wasn't as high as other days, right? But the precipitation was not as high for this particular temperature change. Interesting. In different cities, for those that are watching who are from Seattle or Denver, I'm pretty sure this would not be the same. California has a different temperature. Okay, so how does the relationship between daily temperature range and precipitation differ across city? It's pretty similar. Pretty similar across the days. If you look at the actual data frame in terms of precipitation, I'm still struggling in this video. The descending. The highest is 0.49, which is from San Francisco. I think all these are from San Francisco. Oh, wow. Also, just one of them in a couple of days in San Diego. Okay. Most of these are from San Diego. Interesting. So it's blue. But the highest second is from Slow in San Francisco. Slow, San Francisco. So that is that. What kind of question is a scatterplot especially good at answering? Useful about relationship between two numeric variables, displaying relationship between two numeric variables. Okay, so that's nice there. And last but not least, histogram distribution of temperatures are days with longer temperature ranges, also days with more or less precipitation. Let's go ahead and put this data frame right around here. We're going to be using the long data frame again. Weather long. Take this out. Pipe this in. So X ought to be temperature range. It's a lot of fill in the blank here. Temperature range. Our fill is going to be sorry, I got ahead of myself. This should be temp F. The fill should be temp type. And then in terms of the number of bins, let's say 15. These are all, I'm just, eyeballing this. All right, we're going to make a transportation of 0.25. This is really transparent. Position, let's say stacked. Oh, sorry, my apologies. Identity. That just allows it to be the actual data that it's actually seen rather than anything else, like density. And then color is going to be white. Let's actually see what this looks like before I do anything else. So this would then look like this. Again, these are all three cities on top of each other. So just note that. It's the highs. These are the lows. Let's separate it by city. Okay, you can see the highs, the lows for each city. And then we can then change the color to be what we had before. Tomato and still orange. Tomato and still orange. So instead of looking at it as a line plot, we can look at it as a histogram of data. That's so transparent. Let's make it 0.7. Okay, so you can kind of see those highs and lows across the city. There's a clear distinction in San Francisco, right? Whereas if we were to look at purely just a line plot, yes, there's a distinction, but it's easier seen in this bar, in this histogram. Whereas in San Diego, there's a little bit more of overlap. This data stuff is so cool. What does the histogram? Does a histogram show? The line plot does not directly. It shows where temperatures are concentrated. Shows where temperatures are concentrated. And how they are spread. All right, this video cycle, this ETV cycle was long. It was long for y'all. It was long for me. But I have to say that there was a lot of great learning moments in terms of being able to get this data, bring this data into R, clean it, accordingly using some of the functionalities that we've seen in other videos, especially the library focus method where we just, watch what these functions do. But then we're also then able to create some really nice plots and answer these questions utilizing this ETV cycle. Thank you for your time. We have 1 to 2 more. I'm in between at this current moment because I just love to teach this, concept. It's either going to be another Wikipedia example or going back to the MBA data set and doing some joins with that one. So thank you all. Put it in your comments. I'll look at it. What cycle you're having the most fun with. All right. Thank you.